morning, everyone. Before I begin, I'd just like to thank my mentors, Laura and Daniel, for supporting me throughout this project, as well as RESESS and the National Science Foundation. So the growth of natural gas as a primary energy resource in the United States has led to an increasing demand for hydraulic fracturing or hydrofracking in the Marcellus Shale. The Marcellus Shale, represented in green in this map here, extends over 246,000 kilometers squared in the eastern U.S. and is considered as one of the top 5 gas reservoirs in the country. Between 1990 and 2011, hydrofracking in the Marcellus Shale has contributed alone to 30% of domestic gas production in the United States. And this map also shows a series of unconventional wells being drilled over an 11-year period between 2004 and 2015. So each set of dots is 2 years. And over the 11-course period, there's been 14,000 unconventional wells being drilled in the Marcellus, which is a lot over a very short period of time. However, the states of New York and Maryland currently do not practice hydrofracking, and that's majorly because of the potential risk of methane leaks due to faulty gas well construction. And here's an example of a hydrofracking well, and the center is a production casing, and there are several layers of casing surrounding that with a cemented seal. Now, if there's any pore space or gaps or even fractures from expanding within that seal, potentially methane and other chemicals can come into contact with the formation and migrate towards shallow groundwater aquifers, which are common sources for domestic wells. So methane levels in domestic wells are so concerning because at levels of 28 milligrams per liter, methane becomes saturated in groundwater and begins to degas. And once released, it poses an ignition and explosive hazard. Or in other words, you will be able to light your tap water on fire. But it's difficult to connect hydrofracking to this occurrence because methane is also naturally occurring. And without a thorough baseline record of naturally occurring methane, we can't really contribute how much methane presence is due to hydrofracking versus naturally occurring. So the Shale Water Interaction Forensics Tool Project, or Project SWIFT, uses this opportunity to build a baseline record of naturally occurring methane in the state of New York, in southern New York, outlined here in the blue. And actually, a former RESESS intern, Kayla Christian, started this project in 2013, continued it as her master's studies at Syracuse University, where she and her fellow colleagues sampled 137 wells indicated by these burgundy dots here throughout the southern tier of New York. And then again in 2014, her group, or Project SWIFT, sampled 27 wells with among the highest methane levels throughout her study area. So my role this summer was to go back to those 26 wells, or 27 wells, and gather a third data set for 2016. So, and compare the 3 data sets to see if there's any consistency in methane levels in the southern tier. So this is just a graph of a similar study by Smith et al., displaying the date of sampling collection, which was a 2-month interval over compared to the dissolved methane levels that they observed. And here you can see at the baseline measurement, from their baseline measurement, it varies over time. Methane levels vary over time, exceeding that 28 milligram per liter level, and can be very dangerous. But at the same time, there are some concentrations, like Site E here in January of 2012, has relatively low concentrations of methane. So this just shows why it's important for us to build a time scale, because looking at one snapshot of methane concentrations is not sufficient enough to learn about its behavior. So to collect these samples, we collected water upstream from water systems or water treatment systems such as water softeners to get an accurate reading of the fresh groundwater. And we collected 2 sets of samples. The first we filtered using a 0.45 micrometer filter to get rid of any fine sediments. And the second sample we collected in glass vials using zero headspace method to avoid any air bubbles where methane or other gases can escape. Once we collected our samples, we did a methane analysis at the University of Rochester using the glass vial samples, and we measured for dissolved ions to get an idea of water chemistry at Syracuse University, as well as idea of dissolved metals present in the water at the State University of New York College of Environmental Science and Forestry. So in our results, I compared the methane concentrations from each year to one another to see how well correlated they were. And in this top graph here compares 2016 to 2013 methane levels. This one in the corner is 2014 compared to 2013. And at the end is 2016 compared to 2012 compared to 2016 compared to 2014. And we saw the strongest correlation between methane levels in 2012 and 2013. And that shows us that there is some consistency, 2016 compared to 2013. And that shows that there is some consistency with methane concentrations from year to year. We saw the most variance when compared to 2014. As you can see here in these two graphs, the regressional relationship is at 0.67, 0.64. So that's a very low relationship. And we are assuming that the lower concentrations are the weak relationship between methane levels compared to 2014 is due to difference in sampling techniques. Throughout the 3 years of this study, different sets of students sampled with Kayla to collect these samples, and this year, me and another graduate student sampled. So there could be some variability in sampling technique. Also, we would like to compare precipitation events to the years that we sampled to see if there were any seasonal impacts. So in Project SWIFT, we also developed a classification model of aquifer characteristics that are coincident with high methane levels. And two that we focused on were sodium richness and topographic lows or valleys. So this diagram is just helping us explain the amount of high methane levels that we observed in our total sample size. So we begin with all wells. We had about 7.1% of samples with high methane out of all the wells observed. And then we separate that by water chemistry. So sodium-rich waters compared to calcium-rich waters, where sodium-rich waters had higher percentage of high methane samples. And then we further broke that down by topography, so valleys versus uplands, where we found more wells with high methane concentrations located in valleys rather than in uplands. So with this model, we were able to estimate that there is a greater than 50% probability that we would find high methane in sodium-rich waters located in valleys. So I wanted to compare that to the 26 wells that I resampled this summer. And this graph is just showing each subcategory by topographic region and by water chemistry, compared to the percentage of wells within each category that had high methane, indicated by the purple, and had low methane, indicated by the burgundy. So we actually found that there were a highest percentage of high methane samples in upland regions with sodium-rich waters, which is inconsistent with the classification model that we just reviewed. And we are assuming that this may be because of sample size. And the way that we chose to resample our wells. So in 2013, there was a suite of 658 wells, while I only compared the 26 wells with the highest methane. So there may be some variance there. So this is a summary of what we went over. The close relationship between 2013 and 2016 implies that there is consistent methane concentration in these wells from year to year. And since we saw some variance in 2014, there may be some other factors such as sampling technique or precipitation events that may cause us to have a weaker relationship of methane concentration over the years. And also, as we saw from the classification model and from my data, methane presence in sodium-rich valley settings are inconsistent with my study, and we would like to do more frequent testing throughout the year to see how seasonal impacts methane occurrence and really identify where those differences are in high and low methane concentrations. So in conclusion, our time series will help enhance our classification system, and it will act as a baseline for regions with similar hydrogeology, such as Pennsylvania, that are currently practicing hydrofracking and don't necessarily have that baseline record to compare to. And also, Project SWIFT has developed the data into a public database for local homeowners or other parties to review water quality and learn more information in advance of hydraulic fracturing. Thank you so much. Any questions?
All right, Wes.
So my question is, are you taking this data, right, this data set that you have right here, and you're going to try to tie that in to the potential of gas leaks around well sites where they're actually doing fracking? And is that kind of the long-term scheme of things that you guys are trying to build together?
Yeah. So the long-term goal of this project is to have this baseline time series and compare it to Pennsylvania, which has a very similar hydrogeology, but does not have enough information about the baseline naturally occurring methane levels prior to fracking. And these are regions that have many claims of high methane due to hydrofracking, but there's no way to really tell because we don't have that baseline.
So it would be like a proxy for that area,
right,
to kind of understand that better. Is there any linkage? Has there been any research or any linkage between the comparison between hydrofracking and methane leaks in the? I don't know if there has been yet, so there's no linkage right now. That's what you guys are building towards.
So there was a previous study that compared the methane concentrations in domestic wells to the location to these gas extraction wells, the unconventional gas extraction wells, and they found that there was a high correlation to the location or the proximity to these wells and high methane. So there could be a link between hydrofracking and the presence of high methane, but
I'm just thinking that would make sense for if you're a natural gas company and you're going to go to those areas where maybe there's natural gas in the wells, and so they're going to drill there. That would be a nice correlation if you're looking to make a profit too. So.
Okay, I think Andrew has a question. Andrew, I think your mic is on, hopefully, if you have a question.
I don't know if you could hear me before, but I'll try. So thanks a lot, Crystal, for a really interesting talk. Were any of your samples collected on private land? And if so, how were you able to convince landowners to let you access the area to gather the samples? Because this is something of a controversial topic. Thanks.
Yeah. Thank you for your question. So, all of the wells that we sampled were on private property. We actually reached out to all of our homeowners to request their participation in the project, and actually many of them were very willing to have us come and do this test. I think wherever you stand on hydrofracking, having a baseline methane concentration record is beneficial to both parties. Many of the homeowners that we talked to were felt really fortunate to be able to get a free service of water quality information and learn more about hydrofracking when they've been approached, and just weren't comfortable signing off on it because they didn't know enough information. So that's what this time series acts as, to give more information to homeowners. So they were very receptive.
Great, thanks. Any other questions? No? All right, thank you, Crystal.